Hi Diksha Didi, good evening. Hi, good evening.
Hello, good evening.
Alright, so let's just continue with where we left off. So we left
Yeah,
off
sure.
on inline functions. So let's just have a quick recap. So inline functions were basically those functions where when you wherever you call these functions, whatever their body was, the function's body, there it basically pasted over there, right? So it came over there. Like for example, in a normal function, when you call the function, it goes to the function, right? So the control flow transfers to the function. Then it calls the function, and then the control goes back to your normal program. But when you call an inline function, its body basically wherever you call it gets pasted over there, like, right? So like the inline function, the function call is replaced by its body, right? So there's no control flow transfer and all. So we read about its advantages and disadvantages, so we need not go through them once again. Here's a simple example of an inline function where we have a cube inline function, and what it is doing, it's basically just calling s into s into s. Now s is a parameter accepted by this cube function, and basically making this inline make sense, right? Because if you had this like a normal function, then what it would have done, wherever you are calling cube, it would switch the flow like of the program to the function, right? Then the function will basically do like s into s into s, and then it will switch the flow once again, right? So doing these operations or switching the flow will take much more time than just doing s into s into s directly, right? So when we made this inline, cube 3 will basically just cube 3 will be replaced by s into s into s. So over here 3 into 3 into 3 will come, that's the function body, right? And then it will give us the result. So it will be much faster than switching the flow of the program again and again with normal functions. So when you have small functions that are doing small operations, then using inline functions is always suggested, right? So now we are going to start with something new, inline functions and classes, right? So it is also possible to define the inline function inside the class, so you can create your inline function inside the class also, right? So you have like classes, we read about classes, so inside that you can create inline functions also. In fact, all the functions defined inside the class are implicitly inline. By default, all the functions you create in the class are inline, already inline, right? So thus all the restrictions of inline functions are also applied here, right? So all the restrictions of inline functions will be applied here. So as it is, all the functions are implicitly inline, so they are already inline, so the restrictions of inline functions will also be applied here. So if you need to explicitly declare an inline function in the class, then just declare the function inside the class and define it outside the class using the inline keyword. So basically, what happens with inline functions, by giving the inline keyword, it's not guaranteed that your function will be taken like an inline function. It just hints to the compiler that this function can be inline. Then it checks the what operations is that function doing. If there are small operations, then it basically uses that function as an inline function. Whereas if you are working with like input output, like c out c in, then it would not consider inline function, the functions to be inline, even though you give the inline keyword, right? So it's the compiler's choice to interpret your function to be inline or not, but by giving the inline keyword, you hint to the compiler that this function can be inline, right? But in classes already all functions are inline, right? So if you create a normal function also, by default it is inline, but if it is long and it's doing many operations, then the compiler sees it makes no sense to make it inline, so it does not make it inline and treats it like a normal function, right? So the above style is considered a bad programming style. If you want to create an inline function inside a class and you want to tell the compiler that the function that I'm trying to create can surely be an inline function, then directly giving the inline keyword inside the class and then defining the function there only, it is called it's a bad programming style, right? So the best programming style is to just write the prototype of the function inside the class and specify it as an inline in the function definition. So you have this class s, and if you want to make this square function like inline, so in or you want to hint to the compiler that this function can be inline, so what you can do, you can basically just declare the function inside the class like int square int s, right? So you can just declare the function inside the class, right? And then you can give its body outside of the class, right? So you can give its body inline int s, right? So this is how you will give the body. You will first mention inline, then you will give the return type that this function returns an integer, right? Then you give the class name whose function you want to define, right? Then you give colon colon to access the function, then you give the name of the function, that is square. You give the parameter list, and then you basically give it the body. Right now we have given it no body. Now over here is an example of inline functions with classes, right? So let's just go through this example. Are you just getting with me right now whatever we have done, like right now?
Yeah,
Yes. So in this program, what we have, we are basically including IO stream to use cout, cin and all. Then we have this class operation in which these are private variables. So if we are not giving it under public or protected, they are by default private. So these variables are private. Integers a, b, add, sub and mul are all private variables. Then this float div variable is also private, right? Now next we have this public, we are creating some public function, so we are just giving the declaration over here, right? So we are giving the declaration of get, we are declaring sum, we are declaring difference, we are declaring product, and we are declaring division, right? So we are declaring these functions, right? And outside of the class we can give them their body, right? So we are saying inline void operation get. So basically we are saying inline, to create an inline function we are giving void to mention that it won't return anything. Then we are specifying the class operation class from which we are getting the get function and giving it a body. Now as you can see we have many output input operations. So we are outputting enter first value, then we are taking the input, then we are outputting something, then we are taking the input. So over here, even though we have given the inline keyboard, the compiler won't make this function inline as it is doing heavy tasks over here like cout cin cout cin, right? So basically the compiler won't make this function inline, right? uh, Even though we are hinting to it that this function can be inline, this function won't be considered to be inline. Next is our inline function sum, right? And we are giving it a body. What it is doing, it's adding just two values and it's returning nothing, it's directly printing it. So even though we are making all of these functions inline, right, we are trying to make all of these functions inline, the compiler won't treat them as inline functions. Why? Because we are doing some output operations or input operations in these functions, and when input output operations are done in the function, it is not considered to be inline, right? So next we have our main function, right? So basically these were the definitions of all the functions: get, sum, difference, product, and division, right? So these were just the definitions of those functions. And in our main function we are basically creating an object of the s, or of the operation class, right? And we are just calling all of its functions. So s dot get, s dot sum, s dot difference, s dot product, and s dot division, right? So we are calling its functions. So this was what an example of your classes with inline functions, right? And here is an output. If we give the values of a and b, then we would have that we are giving over here, right? So when we are calling s dot get, it is saying enter first value. It then takes in the input and save that value in a. Then it takes the second value and saves it in b. And then when all of these operation functions, sum, difference, product and division are called, then the values that were stored in a and b are used, right? So we get 45, 15, 60, 30 and 675 and 3, right? So if the user entered some values uh, uh, according to those values, we'll get this output. Now a similar thing to inline functions, but not, also at the same time not very similar, is our macros, right? So in C language macros were introduced, but later it came out that they are not that useful, right? So macros, we are just going to go through macros and how they are different from inline functions. We are going to read about that. So readers familiar with the C language know that the C language uses macros, right? So macros look something like this, right? Over here, there's a wrong example, right? But macros always start with a hashtag. Then you define the macro using the define keyword, and then you give the name of the macro, right? And then you give it a parameter list. So typical macro, what it will look like, let's just keep this macro. It will basically look like something like this. So hashtag define square, for example, right? It will take some value like s, right? And it will basically do s times s. So this is what a general macro will look like. It's basically doing hash define square. It will take s and it will do s into s, right? So macro, its flow is define, then the name of the macro, then the parameter list. You could have more parameters, s, y and all, right? And then some operation. Sorry about that. Readers familiar with the C language know that C language uses macro. So the C language uses macros. The preprocessor replaces all macro calls directly within the macro code. So we will read about preprocessor further if you continue with the course, but right now preprocessor is not important. Basically what is done with macros, wherever you call the macro, for example, you over here just doing s like square, and you're passing it 5. So over here this command will be replaced by 5 into 5, right? So this is how macros work. So it is recommended to always use the inline function instead of the macro. So inline functions are very similar to macros, but it is always recommended to use inline functions over macros. So according to Dr. Bijan Stroustrup, he is the creator of C++, macros are almost never necessary in C++. So macros are almost never necessary in C++ as you have inline functions, right? And they are error prone. So macros are very error prone, right? So it's not suggested to use macros. There are some problems with the use of macros in C++. For C these were created, but in C++ when you're using macros, there are some problems when doing that. So macro cannot access private members of the class. So macro cannot access private member of the class. That is kind of a false statement, because macros like this over here in this example, the macro is not being defined properly. What is being happening over here in this example is that we are defining a macro in where in its parameter list only we are trying to access the private member of the class. So in the parameter list we have to have a variable which value will be passed. So for example, you have this macro square, right? So you are creating a variable over here s, whose value will be passed. S value will be passed when square will be used, right? Right now we don't know what will be the value of s, right? So we are waiting for s value to be passed when the square macro is being used. But over here in this example, what we are trying to do, we are basically saying s colon colon m. So we are trying to access m of basically this s class. So in the parameter list, that is not possible. What was possible was, for example, you're calling macro and passing it s colon colon m. This is possible, but this straight up does not make a sense, only as you need a variable over here, like for example m, that will be able to use the value that will be passed. So like if you had a variable over here, then you can basically pass s colon colon m, right? So the example over here, I'll say, is wrong, right? So the example given over here, stating that macros cannot access private members of the class, this example itself is wrong. For example, I just take m and give it under public. Okay, so it's not signed in, but if we give it under public also, then also it will basically just not work, right? It will give this same error that this cannot be there over here, right? So the example over here was given wrong. Like macros can actually access private members of your class, right? So macros look like function calls, but they are actually not. So this is a true statement, that macros look like function calls, but they are not. So when you say square, like 5, this is not a function call, because over here 5 into 5 is coming. But for example, you had an inline function, you can argue that this is same with inline functions. If we had a square inline function, then also we would have gotten 5 into 5 in its place. But you can clearly see some differences. First of all, before s we do not need to specify any type like int, right? We do not need to do that. Second of all, we are not creating it like a function that has a return type and all, right? We're just using hash define. So this looks like a function, like when we are using a macro like this, it's looking like a function, but it's actually not a function, right? So C++ compiler checks the argument types of inline functions and necessary conversions are performed correctly. So it the compiler checks the argument types of inline functions, right? So what type of or in inline function, not in macros, and inline functions. So for example, you have an inline function void x and int y, right? So this compiler will check the argument types of inline functions, and when you call like x, so like 5.5 you're passing it, then the compiler will check what type of value you're passing, right? And necessary conversions are performed correctly. So it also converts the value in some way, like that's the compiler's works. Some necessary conversions are performed. The preprocessor macro is not capable of doing this. Now the preprocessor macro is not capable of doing this. So whatever you pass to square, right? So whatever you pass, anything, that will basically be accepted as its value. For example, if you pass infinity, right? So what will happen, it will basically replace this piece of code with infinity times infinity, right? Infinity, right? So necessary conversions are not done when using macros, right? So one other thing is that the macros are managed by the preprocessor and the inline functions are managed by the C++ compiler. So when we come to the preprocessors chapters, then we can dive deeper into this, remember, it is true that all functions defined inside the class are implicitly inline. So by default, all functions defined inside a class are already inline, and the C++ compiler will perform inline calls of these functions. So the C++ compiler will perform inline calls of these functions. It will try to use them as inline functions. But the C++ compiler cannot perform inline if the function is virtual. Now, virtual functions are those functions that are inherited by the class. For example, when we learned about classes, we saw class inheritance, right? So, like operation, any class can be inherited by operation, right? For example, an X class is inherited by operation, right? Then what will happen, these all functions that are there in the operation class, so these all functions, get, sum, difference, product, division, will be virtual functions. These functions will be inherited in the X class, right? So if you have an X class that is inheriting from operation, right, uh, and basically then the functions get, sum, difference, product, and division, these all will be virtual functions, right, that are likely to be changed inside the inherited class, right? So these all will be considered as virtual functions, right? So inlining cannot be performed if the functions are virtual. The reason is call to a virtual function is the reason is a call, so it's written wrong over here. The reason is that a call to a virtual function is resolved at runtime instead of compile time. So when you are inheriting from operation, then you do not know which sum to call, right? To call this sum method or the sum method inside of the inherited class, right? So for example, X is inheriting from operation and it's calling the sum method. The compiler does not know which sum method it is calling, the sum method that is defined inside operation, or the sum method that is being overwritten inside the X class, right? So that it does not know. So the reason is that call to a virtual function is resolved at runtime instead of compile time. So this which function sum will be called, that is resolved at runtime, not at compile time. So virtual means waiting until runtime, and inline means during compilation. So when you have virtual functions, you have to wait until the runtime, so to know which function to call, like to know which sum function to call, right? And at compile time, inlining is being done. So if you do not know which function to call, then how can you perform inlining at that time, right? So virtual functions are not basically considered to be inline functions, right? So one other thing to remember is that it is only useful to make the function inline if the time spent during a function call is more compared to the function body execution time, right? So this is an important thing to remember, that you should make the function inline if the time spent during a function call, so like switching between the function and between the global scope of the switching the scope of the program to the scope of the function and then back to the program. If that switching that execution time is more compared to the function body execution time, then only you should make a function to be inline. Like over here, show function, making this function inline does not make any sense, because you are doing the switching time is less than the function body execution time, right? So that's why making this inline does not make sense. You are giving inline, but it won't be actually inline, right? So the above function relatively takes a long time to execute. This function will take a long time to execute, as cout you're using cout, that's an input output operation, right? So that's an output operation, so you that takes time, right? So the function body execution time is more than the function function call uh, right? So the function call, the time it's taking to call the function is less than the function body execution time, right? So that's why making this inline does not make sense. So the above function relatively takes a long time to execute. It's not doing much, it's just printing some value, but it relatively to other functions that are not doing an output operation, it relatively takes more time to execute. In general, a function that performs an input output operation shouldn't be defined as inline because it spends a considerable amount of time, right? So input output operations wherever are done, there a considerable amount of time is taken, so they should not be uh, specified as inline functions. Technically, inlining of the show function that is over here is of limited value because the amount of time the input output statement will take for far exceeds the overhead of a function call. So the overhead of a function call is much less than the execution time of this statement over here. So making this inline does not even make sense. Depending upon the compiler you are using, the compiler may show you a warning if the function is not expanded inline, right? So this is basically compiler specific, that some compilers may show you a warning if the function is not expanded inline, right? So programming languages like Java and C Sharp don't support inline functions, but in Java the compiler can perform inlining when the small final method is called, because the final methods cannot be overridden by subclasses and the call to a final method is resolved at compile time. So basically in Java you have, after completing the program, you have a final method that needs to be called, and though you cannot create inline functions yourself in Java, but inline functions, this concept exists in Java and it is applied on that final method, right? That final method. So there's a final method that needs to be called in Java, and that function is considered to be inline in Java. So in C++, JIT compiler can also optimize code by inlining small function calls. Like same Java and C Sharp don't support inline functions, but they internally can perform inlining, right? So like C Sharp can optimize the code by inlining small functions, function calls, like replacing the body of a small function when it's called in a loop, right? So basically when you have small function calls, then inlining can be performed internally by C Sharp, and Java performs inlining on its final method, but you yourself in these languages cannot perform inlining. So last thing to keep in mind is that inline functions are a valuable feature of C++. Appropriate use of inline functions can provide performance enhancement, but if inline functions are used arbitrarily, then they can't provide better results. In other words, don't expect a better performance of the program. Don't make every function inline. It's better to keep inline functions as small as possible, right? So you should not make all functions inline. It's better to keep them as small as possible, right? So whatever inline functions you create, those should be as small as possible so that you make full use out of them, right? These were our inline functions. Now we can move on to the lambda functions if you have no doubts. So if you have any doubts, please feel free to ask.
No, it's clear.
All right, let's move on to lambda expressions in C++. Now C plus lambda functions are another, like in many languages they are just another way of defining or using functions, right? These are also small functions, right? So you can't have these functions to be as big as normal functions, but yeah, they have their own use cases. So C++11 introduced lambda expressions to allow inline functions which can be used for short snippets of code that are not going to be reused and therefore do not require a name, right? So these functions are used to basically write short snippets of code. So these are short, right? And they don't have a name, so you cannot reuse these functions. So in the simplest form of a lambda expression can be defined as follows. So over here, this is an example of a lambda function. So you have a capture clause that we are going to see about. You have normal parameters, you have the return type, that what type of value it will return, and then you have the definition of the method. So generally, the return type in lambda expressions is evaluated by the compiler itself, and we don't need to specify it explicitly. Sorry about that. So so the return type in lambda expression is evaluated by the compiler itself, right? So this is not always required, right? And you don't need to specify it explicitly. So the compiler will find out what return type you are giving. However, in some complex cases, like conditional statements, the compiler can't determine the return type, and explicit specification is required. So when you are working with conditions, like if something happens, then return this value, else return this value, then the compiler is not able to decide what is the return type. So you have to explicitly mention it. So various uses of lambda expression with standard functions are given below. So here are our use cases of lambda functions, right? So this is one of the basic ones over here that is very important. So we have basically a square, like square is the name of the lambda function. So as I told you, there is no name of your lambda functions, but we are storing this function inside a variable, right? And this auto keyword is saying that detect the lambda functions type itself, right? So the data type, it will basically detect itself, but you are storing it in a variable. And likewise, you are giving a name to the lambda function. Like, so by using this technique, you can actually give a name to the lambda function, though there's no way you can give it like normal functions, right? So you have to save a lambda function in a variable, and then you can reuse the lambda function. So here we have a square lambda function that is taking in a variable I, and it's just returning the square of I, that is I into I. So wherever we call this lambda function, it will be executed, right? Normally, let's see examples. One more example with like vectors. So over here we are accepting a vector, right? So vector is like a collection, right? So we will read about this, but vector is like a collection, right? So a collection of values. So over here in this print vector, we are just trying to, whatever vector is passed, we will try to print that, right? So we'll loop for each. We'll start from the beginning of the vector till the end, right? Then we are giving this callback function that will be called for each item of the vectors. Like over here we have the vector that is 4 1 3 5 2 3 1 7, right? When we call print vector and pass v to it, then we are looping on this vector, right? And this first gets 4 and it prints 4. Then this function gets 1 and it will print 1. Then this function will get 3 and it will print 3, and so on until it reaches the last element of the vector, right? So over here, as a callback function, this is called a callback function, right? So like when you're passing the function to for each, then this is a callback function that is being called for every item inside the vector, right? And one more example, let's go with sort example. Over here we are from the beginning till the end of the vector, we want to sort it, right? So this will basically take in a reference variable a and then a reference variable b, and then it is returning a bool that we are specifying over here, right? And basically the sort has an algorithm that when it receives true, it does something. If it receives false, it does something. So a greater than b, right? So basically sort has an algorithm. So when this will return true, it will do something. When it returns false, it does something, right? So the sort function has its own algorithm. The major part of this example was explicitly defining the return type, that is boolean. So as you can see here, there's a condition given, a greater than b, right? So the compiler cannot decide what type of value is being returned, so that's why we have to explicitly define that a boolean will be returned, right? Very, very cool. Now all the other examples are not important, they have vectors and all those concepts, so we can leave them for later. So lambda main thing that we need to know in lambdas is that, like right now we are just seeing that they are like normal functions, but the capture clause is what makes them different. This small array thing, that is what it makes them different. So lambda expression can have more power than an ordinary function, right? By having access to variables from the enclosing scope. So you can define how the variables around the lambda function will be accessed using this capture clause. So we can capture external variables from the enclosing scope in three ways. So we can capture by reference, by value, and by both, right? So we can basically say and, right? So we can say we can give an and inside of our brackets. So what this will say, that access the enclosing variables, so the variables that are outside the lambda function, access them in such a way that they can be modified, right? Equals to says that access the variables that are surrounding the lambda function in such a way that they can be used by the lambda function but not be modified. And then a and b is saying that capture a in such a way that it can be used but not modified, and capture b in such a way that it can be also used and it can also be modified inside the lambda function, right? A lambda with an empty capture clause with empty brackets can only access variables which are local to it, right? So variables that are defined inside the lambda, those can only be accessed when these brackets are empty. Different methods of capturing are demonstrated below. So over here in this function we have vector 1, vector 2, right? And then we have this push into lambda function, right? Over here we are accessing the surrounding variables by reference. So we will be able to change v1 and v2, right? So we will be able to edit these two inside the function. We are also taking in a parameter m, right? And we are basically just calling pushback m to basically add a value to both these vectors, right? And then we are just calling push into 20, and we are basically adding 20 to both the vectors. So we are being able to edit them because we have given and over here. If we are giving v1 over here, saying that we want to access v1 by copy, right? So we cannot change it, but we can only use v1, right? So we are only able to use v1. Now in this example we are given n, so we will be only able to use n, we won't be able to change n, right? And then in this example we are giving equals to, that all the surrounding variables we will be able to use but we won't be able to change inside the lambda function. So note, lambda expressions are available after C++11, and this was our lambda functions. If you have any doubt, feel free to ask.
No, no, it's clear.
All right. So we have completed our part one of our advanced course. If you would like to continue, then we can schedule for part two where we are going to learn more advanced concepts. But for now, we are over with part one of the advanced course, and I hope you like it.
Yeah, it was nice.
Yeah. So thank you for
Mm.
joining, and
Thank you.
thank you.